Okay, so for this problem, we're going to repeat what we did for questions 1 and 2, but except with capacitors instead of resistors. So now we're going to have two capacitors in series across the battery and in parallel across the battery. So for the first part, part A, I've got a 5 and a 7.5 microfarad capacitor in series, so one right after the other across the battery. I've got 10 volts, 5 microfarads, and 7.5 microfarads. And I want to find the equivalent capacitance, the charge, and the voltage on each capacitor. So when they're in series, we know the equivalent capacitance. We add up the inverses. So we're going to do 1 over 5 plus 1 over 7.5 to the minus 1. And if I do that, I get exactly 3 microfarads for my equivalent capacitance. For capacitors in series, Q is the same and V is different. Okay, so if I draw my equivalent circuit, so again, I'm doing the same steps that I did for the resistors. Draw my equivalent circuit. So I've got my 10 volt battery and now a 3 microfarad Q total. I know my equation is, so for batteries and resistors, I use Ohm's law. For batteries and capacitors, I use Q equals CV. So Q total is equal to C total times V. So that's 3 times 10 volts on the battery. So I get 30 microcoulombs. So this 3 microfarads, I really should have put that as 3 times 10 to the minus 6. And so I get 30 times 10 to the minus 6 coulombs. All right, what's the voltage? The voltage on each one, if I use Q1 is equal to C1 times V1, and Q2 equals C2 times V2, I can get the voltage on each of those two, and those two voltages should add up to give me the total voltage on the battery. Okay, so what's the charge on them? Well, when the two things are hooked up like this, if I have a total charge of 30 microcoulombs on this individual capacitor, the same thing is going to happen here. So I got a charge of plus 30 on this side, a charge of minus 30 on the far right side, and in between, because this is a capacitor, there's an insulator in between, there's no charge in there. The net charge is 0. So Q1 is equal to 30 microcoulombs, and Q2 is also equal to 30 microcoulombs. So they're both the same charge on each other. So if I want to find V1, it's equal to Q1 over C1. So that's 30 microcoulombs, 30 times 10 to the minus 6, over C1, which is 5 microfarads. So I need to put in my micro, 10 to the minus 6, and I get 6 volts on that one. V2 is 30 times 10 to the minus 6, same charge. Q2 over C2. C2 was 7.5 microfarads times 10 to the minus 6, and I get 4 volts. And again, I can do my double check that V1 plus V2 is equal to the voltage from the battery. So 6 plus 4 is equal to 10. Okay, so it's always easy when you're doing these kind of circuit problems just to double check that you did it right. All right, so let's do the same thing with them connected in parallel. So let me pull this up. And I've got now my battery. So remember, a battery has a long and a short, and a capacitor has two the same length. So now I've got my two capacitors like that. So C1, C2, and there's my 10 volt battery. So we know when two things are hooked up in parallel, V is the same, and now Q is going to be different. Right, so what's V going to be? Well, both of them are hooked up right across the battery. So V V1 and V2 are going to be the same as each other, and they're going to be the same as the voltage on the battery. So they've got 10 volts across them. How can I find the charge? Well, Q equals CV, so Q1 is just going to be C1 times V1, which is 10 volts. So it's going to be 5 microfarads, 5 times 10 to the minus 6 farads, times 10 volts. So I'm going to get 50 microcoulombs. Q2 is going to be C2 times the voltage on it. So 7.5 times 10 to the minus 6 farads times 10. So I'm going to get 75 times 10 to the minus 6. Of course, when you guys put this into your calculator, if you don't do it mentally, you'll get 7.5 times 10 to the minus 5, which is the same as 75 times 10 to the minus 6. Okay, so I've got my voltages, I got my charges. So just like I did in question 2, I sort of worked backwards from question 1 when they were in parallel. I'm doing the same thing here for capacitors in parallel. All right, so what's the last thing? The last thing was to find the equivalent capacitance. All right, so in parallel, C equivalent is just equal to C1 plus C2. So it's just going to be 5 plus 7.5. Which is going to be 12 microfarads. So equivalent capacitance is that. Right. If I wanted to do a double check, I could draw my equivalent circuit. So I've got one battery, one capacitor. So I've got 12.5 microfarads and a 10 volt battery. So my Q total should be equal to the sum of the two charges. So what's Q total? Q total is going to be the voltage on the battery times C total. So 10 times 12.5, which is 125 microcoulombs. And again, I can do my double check. Is 50 plus 75 equal to 125? Yes, it is. So Q1 plus Q2 equals Q total. Okay, so for capacitors in series, the voltages are different, and the total voltage should equal to the voltage on the battery. For capacitors in parallel, the charges are different, and the total charge should equal to the total charge that comes out of the battery, the charge on the equivalent capacitance.